Hello everyone, welcome back to CS Concepts. I hope you all doing well. Okay, over the past few months, I haven't been able to upload any videos, but I'm excited to let you know that from now on, I'll be uploading regularly. Your support means a lot to me and I truly appreciate it. Moving forward, I'll be focusing on data structures and algorithms. So in this video, we'll dive into our first topic, the bubble sort algorithm. Let's get started. Bubble sort algorithm. It is a basic sorting algorithm that operates by repeatedly swapping neighboring elements when they are in the wrong order. Now let's see how to implement this algorithm using Python programming language. Okay, first let's define a function named bubble sort of ARR. So this ARR is the name of parameter. It represents the array that the function will accept when it is called. Okay, in the next line of code, we need a variable n to store the length of array. So n is equal to length of ARR. Okay, then we need to start outer loop for I in range of n. Okay, so this outer loop runs up to n times, corresponding to the number of passes required to sort the array. I represents the current pass. Initially, I is equal to 0. Okay, then swapped is equal to false. Okay, this line of code is to check if any swaps occur in this pass. I'll explain about the swapped flag later in this video. Now let's move on to the next line of code. Next, we have inner loop for comparisons. For j in range of n minus I minus 1. Okay. So this inner loop compares adjacent elements and it reduces the range of comparisons, that is n minus I minus 1, because the largest I elements are already sorted after each pass. Okay, then we need this line of code. If ARR of j greater than ARR of j plus 1. So this line of code is used to compare two adjacent elements. Okay, then so if it is out of order, if the two adjacent elements are out of order, we need to swap them by using this line of code. ARR of j comma ARR of j plus 1 equal to ARR of j plus 1 comma ARR of j. Okay. In the next line of code, set swap is equal to true to indicate a swap occurred in this pass. Okay. After the inner loop finishes, check the swapped flag. If swap is equal to false, no swaps occurred in this pass, so the array is already sorted. Okay. If not swapped, so exit the loop early using break. Okay. Then we need to repeat this process for the next pass, reducing the comparison range. Once the sorting is complete, return the sorted array. So return ARR. Okay. The array we are going to sort, let it be numbers is equal to some values. Let's give some values. 64 comma 34 comma 25 12. Okay, then we need to call the function, right? So sorted numbers is equal to bubble sort. So we'll pass these values as arguments, okay, numbers. Then we need to print the sorted array. Sorted numbers. Now let's run this program. Okay, we have got some error in line number 7 and line number 13. Let's see. In line number 7, let's check. Error of j comma error of j plus 1 is equal to, if this line is for swapping, right? Okay, I have made a mistake here. Instead of comma, I have typed plus. So it should be comma here. Let's check the output again. Yes, we have got the sorted array 11, 12, 22, 25, 34, 64, 90. So this is the entire code and we have got the output also. Earlier in this video, I told you that I'll be explaining about swapped flag. Yes, now I'm going to explain about it. After then, I'll explain about the working of outer loop and inner loop. Now let's know about this swapped flag. In line number 4, you can see swapped is equal to false. This flag plays a crucial role in optimizing this bubble sort. It is used to detect whether any swaps were made during a particular pass of the array. Let's break it down step by step. What swapped is equal to false does. At the start of each pass, this flag is set to false before the inner loop begins. Okay, so this assumes that no swaps will occur unless proven otherwise during a pass. Okay, then during each comparison, we have if statement, no? If error of j greater than error of j plus 1, that's what. If two adjacent elements are out of order, they are swapped. The flag is set to true because a swap has occurred, indicating the array is not yet fully sorted. Okay, then at the end of the pass, so after the inner loop completes, the flag is again checked. If no swaps were made, so swapped is still false. It means the array is already sorted and the algorithm terminates early. That's all about swapped flag. Now let's see the working of outer loop and inner loop. What we have in outer loop is for I in range of 7 and inner loop for j in range of 6. This inner loop range reduces for each pass. This is n minus I minus 1. Okay, so what is initial value for I? It is 0 and j is equal to 0 at start in this pass 1. Then the value changes for j in this pass 1. Okay, so for j equal to 0, let's substitute here. This is the condition. If error of 0 greater than error of 1. What we have in 0th index? 64 and in 1 34. So 64 is greater than 34, right? So swapping occurs. In this line of code, swapping occurs. Okay, 0 comma 1 and that is equal to 1 comma 0. So now 34 comma 64. Okay, then j value changes. J equal to 1. So if error of 1 greater than error of 2. Okay, so what we have in 1? 64. So 64 greater than 25. Okay, again swapping occurs, 25 comma 64.
So for each value it checks the condition j equal to 2, j equal to 3, 4 and 5. See, actually for this pass 1, what is the range for j? It is 6. Okay, so it runs till range 5. So for each j value, what happens is it checks the condition and then swapping occurs. So the final result in pass 1 is this. Okay, and for j equal to 5, no swapping occurs because error of 5 greater than error of 6. What we have in 5? 64 greater than 90. 64 is not greater than 90, right? So no swapping occurs. Okay, pass 1 is over. Now we have to move on to pass 2. Okay, now it's pass 2. I value is incremented to 1 and j is equal to 0 at start. I range is 7 and j range is 5 now. So it runs till 4. This is the array we have got from pass 1. So check the condition if error of 0 greater than error of 1. What we have in 0? 34. 34 is greater than 25. So condition is satisfied, swapping occurs. So this process repeats till j equal to 4. What we have in j equal to 4? Error of 4 greater than error of 5. 34 greater than 64. Condition is not satisfied. So no swapping occurs. Pass 2 is over. Okay, now let's move on to pass 3. Okay, now it's pass 3. I value is 2 now and j is equal to 0 at start. I range is 7 and j range is 4. So it runs till 3. So this is the array we have got from pass 2. So it checks the condition again. Error of 0 greater than error of 1. 25 greater than 12, right? So swapping occurs. So this process repeats till j equal to 3. What we have here? 25 greater than 34. Condition is not satisfied, so no swapping occurs. Pass 3 is over now. Let's move on to pass 4. Okay, it's pass 4 now. I value is incremented to 3 and j is equal to 0 at start. I range is 7 and j range is 3 now. So it runs till 2. This is the array we have got from pass 3. Okay, so condition error of 0 greater than error of 1. 12 greater than 22. Condition is not satisfied for j equal to 0. So no swapping occurs. Okay, in pass 4, now j value is 1. So it checks the condition for error of 1 greater than 2. 22 greater than 11. So condition is satisfied. So swapping occurs 11, 22. And then j equal to 2. See here, 22 greater than 25. Condition is not satisfied, so no swapping occurs. Pass 4 is over. Now this is pass 5. I value is 4 and j is 0 at start and j range is 2. Okay, so it runs till 1. Let's see. We have error of 0 greater than error of 1. 12 greater than 11. Condition is satisfied, so swapping occurs. Then in next we have j equal to 1. Here condition is not satisfied. 12 is not greater than 22, so no swapping occurs. Okay, so in pass 6 we have I is equal to 5 and j is equal to 0. Okay, and j range is 1. Okay, so this is the result we have got from pass 5. So let's see. Actually the array is already sorted. Okay, it checks the condition, for the first two elements. 0 greater than 1. 11 is not greater than 12. So no swapping occurs. So what happens? It exits the loop. Okay, so that's it.
That's all for today's video. If you find this video helpful, like and share. Then subscribe CS Concepts. If any doubts and suggestions, let me know in the comment section. Thanks for watching CS Concepts.